Today's show was recorded live at London's Natural History Museum on November 24th, 2025. You can watch the video versions of this and past conversations at our website, singforscience.org. Please be sure to check out our other episodes, including one with actor Hank Azaria as Moe from The Simpsons on the topic of social neuroscience. Don't forget to click subscribe and please rate the show on your favorite podcast platform. This is Sing for Science Labs. I'm your host, Matt White. Each episode in this series brings together artists and scientists to explore a topic of shared interest. Tonight's topic is the chemistry of Breaking Bad, and our guests are Emmy Award-winning actor Bryan Cranston and London Natural History Museum mineralogist Alan Hart. From 2008 to 2013, Bryan Cranston captivated international audiences with his portrayal of Walter White, the meek high school chemistry teacher turned terrifying drug kingpin on the hit series Breaking Bad. Much of Walter's development is tied to his identity as a scientist, and the show gives as much attention to its science-driven scenes as it does to the violence that made for some of its most unforgettable moments. The show's opening titles have become an iconic representation of the periodic table, which, as we'll learn tonight, owes its origins in large part to the field of mineralogy. Also joining us is renowned mineralogist Alan Hart. Mineralogy is the study of mineral substances, from gemstones on the geological scale down to the atomic structures that reveal a complex crystal chemistry. Alan has spent most of his career at London's Natural History Museum, starting at the young age of 16 as an assistant scientific officer and rising to become principal curator of gems and minerals and later head of Earth Sciences collections. Mineralogy has a long history, but it was during the Enlightenment that it became a truly scientific discipline, one whose study of crystal structure and elemental composition helped shape modern chemistry and modern physics. Museum of Natural History, please help me welcome Bryan Cranston and Alan Hart.
Hello. Good evening.
Thank you for joining us. So, among the many nagging questions I had when watching Breaking Bad, is I always wanted to know how much of the science you actually had to internalize. In other words, if there was a particularly science-dense scene, did you have to research beyond the words in the script?
Oh, yes, of course. When I knew that I had the role, I immediately, in Southern California, I called the University of Southern California and talked to the dean of the chemistry department. And I told him what I was doing, and I asked if I could shadow him and just follow him around. So I went to see what he was doing and then broke off and saw what his teachers were doing. And it gave me a new appreciation for the science itself. And so that's what I really focused on. My character went through a series of traumatic situations like having cancer, and I wanted to learn about that as my character was learning about that. So I didn't really focus on that. It was just the chemistry. And there's a line in the very first episode of Breaking Bad that is really kind of rudimentary, but I think is true. You tell me if you agree to this. He says, chemistry is really the study of change.
That is true.
There we go. Good night, everybody.
Okay. Revealed.
Yeah, because a gas or a mineral or a liquid could be inert until something else is added to it, and then it could be, explosive, or it could change form, which is fascinating. And I just didn't appreciate it when I was in high school and going to chemistry class then, because, well, even when they would call it the periodic table, it's not periodic, it's constant. It's not a table, And then, you know, they would give like iron, Fe, iron, right?
Definitely.
It's only there to mess with you. Why would they say Fe for iron?
That's just a simple notation to make. You don't want to say iron all the time. And actually, if you put all the element names on the periodic table, it would be 10 times the size.
See?
So it's a case of doing an abstract, universal system of classification by 2 letters or 1 letter. And then if you're a good chemist and you know your stuff, you will know the name of the element. It's quite a good test for people.
Yeah, very good.
So you had internalized it to the degree that you could improv and just sort of riff about chemistry?
Oh, no. No, because there is no improvisation to science. It either is or it isn't, unless it's unproven and you're experimenting, and then anything is possible. But what we were dealing with was known. It was known science. This is how you do it. In fact, the Drug Enforcement Agency consultants on our show were chemists, and they taught us how to make crystal methamphetamine.
Wow.
Okay, I take back what I said earlier. We are going to learn how to make drugs.
We did, but as soon as we learned it, it's very difficult and very specific, and that's why you hear often of the people who are trying to replicate that recipe are often doing something erroneously and they blow themselves up. I mean, it's a dangerous thing. And in fact, when we were putting the show together, we never showed the accurate and timely precision of how to do. We didn't want it to become a video on how to make crystal meth.
What this is tonight. Yeah,
I know.
that was for this.
When I watched the series, I noticed that you took one method of making it, and then a scene later, it was using a different method. So you didn't show the actual process.
Exactly.
Chopped.
Exactly. Or we would put something out of order. We would put a process out of order, or we'd leave a couple things out of the showing it so we could. But I would imagine that there were some knuckleheads out there watching the show and then trying to cook, you know.
Oh, I'm sure. We just played a scene from the show's pilot where Jesse, your cooking partner, makes the distinction that cooking meth is an art and not science, or not chemistry, and Walt seemingly bristles. And I'd like to ask you to speak to how you embody Walt's role as a scientist, as an actor, how you prepared to be a scientist. So, for example, how would you explain Walt's perspective, if I've got that right, if he does reject Jesse's idea that it's art and not chemistry?
Just the connotation of art is subjective, isn't it? I mean, we look at a piece of a painting or a sculpture and we all decide whether we feel that's artistic or not, whether we like it or not. Science is not that way. Science is or it isn't. And so it was nice for me to then go and just start the very beginning stages of learning what actually is and how something progresses, how something is thought of. And I wanted to know as much as I possibly could. So every time that there was a classroom scene or I was teaching young Jesse how to do this in the Winnebago, I wanted to know the differences between a boiling flask and you know, other equipment that you know I've now all forgotten. Yeah. It's the one thing that actors do. We become temporary experts in something. I remember I played an astronaut from the Earth to the Moon, and over the course of those several months, I would just study and study and study, and you become a little nerd about science and space. But sure enough, when that's done, you're moving over. Now I'm playing the cowboy, and so that starts to erode because you're not keeping it fresh. You know?
I think though, from a scientist's perspective, science is very artistic. You become to appreciate more artistically science than real science itself.
Well, how can you describe that?
Well, I
Why
think
is it artistic?
it's artistic because in science you try to make a hypothesis and look at prediction. And then once you've got the prediction, you have a sense of awe that you've discovered something. And then there's almost a beauty in the process that you've been to get an answer that you may think is right or may think is wrong. But I'm lucky to work in a discipline that has beautiful crystals and beautiful gems, but by nature look spectacular. They elicit emotions. We wear gemstones for wealth. We show why we like them. But for me, it's the geometry of the crystals that reveals something that you don't really see every day in nature. You see the organic life on Earth, it tends to be more flowery or more organic in terms. That's what it's meant to look like. But crystals are very geometric. They've got symmetry. And when I look at modern art, I can see that. My crystals that I look down a microscope, what I can hold in my hand, I can see them reflected in the art that was there. And I think that's been like that since the dawn of humanity, really, because there was a fantastic paper a few months ago in Nature, where in the Kalahari, they found that they were digging, there were Homo sapiens was living there 105,000 years ago, and they found this discrete cache of calcite crystals, which is like rhombohedral crystals, all lined up. And they dug through this, and they think this is not a tool, because it's too soft, the mineral. And then they dug down, they found another cache all lined up. And then they found some shells that were not for eating, but they had holes in them where they've obviously been worn as necklaces. And I think this has been looked at as the world's first mineral collecting human. And what it is, I think that they found the actual cave that these were collected from 2.5 kilometers away. So people have made the trek, collected material that they didn't understand, but it was at start with the geometry, and probably just laid them on the floor, and that's where they sat. 105,000 years ago, they dated some of the minerals and the sediments there, and they got a good chronological date from the actual minerals themselves.
Bryan, you're talking a little bit about what it was to know Walt as a scientist, and another thing I always wanted to know was why Walt, a chemist, chose Heisenberg, a physicist, as his alter ego.
I would just say that I'm uncertain.
Hello.
This was a narrative scripted show that needed to work a little backwards. So the conceit was that he was a man who was going to do something terribly illegal in order to achieve a certain goal to satisfy his needs for his family before he dies. And so you elicit compassion from the viewer because you can understand if you were put in that position, what would you do? What decisions would you make? And so he chose that he would become a drug manufacturer and a drug dealer, which is dirty and awful. And so by virtue of that end result, he had to go, well, how can he do that? Well, he has to be a chemist then in order to be able to know that. And I say that because had Vince Gilligan, the creator of Breaking Bad, decided that Walter White was going to count cards in a casino to make his money, well, he would have made him a mathematician then. So it was a necessary element to be that person. I actually did know at one point why he chose Heisenberg to be his name, but I actually don't remember what that answer was. Is that satisfying?
Well, Alan, I believe you could offer some speculation.
I can try, but Heisenberg was a great physicist, and I read some of his autobiography. And one of the things about Heisenberg was that he read Plato a lot, the Greek philosopher. And Plato used to say, like, when you look at the world, don't think about the material things, but think about the form of things. And the form of the world is underpinned by mathematics. So when he was really young, he learned maths, and when you look at the other people around him, like Schrodinger, we read about Schrodinger's cat, Schrodinger, Max Born, they were very much brought up in doing physics. So he thought mathematically, and the others thought physically, in a sense. So when he became to devise the laws of quantum mechanics, it was only 23 when he made the uncertainty principle. And I think what's amazing is that there was quite a competition between Schrödinger and, and Heisenberg. So it was a physicist versus the maths, and there's a lot more physicists then doing unraveling the universe than the maths. But he used the matrices, which are a mathematical way of describing the world, and he did this uncertainty principle. And I think people realized just how brilliant it was. And he had really, what I love about this, talk about science and art, that Heisenberg had really bad hay fever. So he took himself off to an island off Denmark called Helga, which is just basically a rocky island. And he sat there and he spent a few weeks there. And this is where he got this uncertainty principle from. And he said, at first I did the maths, I did my matrices, and I thought about the world. And suddenly it hit me, and I was so alarmed by what I'd found. But then I became supremely calm with great beauty.
It's like the Beatles with Maharishi.
Absolutely. You can call it what you will, but in the maths and what he absolutely discovered, he felt peace almost. And then he developed the uncertainty principle that no one understands. Quite amazing.
I don't know if that's a ripcord you just pulled, but I was hoping to ask you to explain what is happening in that equation.
I can try, but
Okay.
I was going to say I'll be certainly uncertain that I might not be able to describe the uncertainty principle. This is still being debated today.
Oh, okay.
I think the main thing about this is you've got these formula, very simple formula, X and P. So imagine that a wave and a particle can describe matter. Matter could be a particle or a wave. X is the particle, P is the wave function, the momentum of that particle.
And it can be both.
Can be both. So it's all about probability. So the delta there, the triangle is the probability of X and the probability of measuring P. Now, if you try to measure both in the quantum world, you just cannot. You will break the structure of the universe. It just doesn't allow you to do it.
Just from doing that one equation, it all goes to hell.
And that H bar, that's the Planck constant, which is the smallest unit of length you can measure without breaking the universe. And it's so small, it's ridiculous. So if I was to say to you, if I had a carbon atom, and I was to count the number of Planck lengths in that atom, I'd start at one edge of the atom and go 1, 2, 3, 4, 5, 6, 7, 8. It would take me 10,000 times the age of the universe to get to the other end.
Well, that's small.
So it's that small. So really, that is just, I'm going to say, it's such a small number that if you try to find the probability of where the particle is and the momentum, you'd have to put more and more and more energy in to be able to view that. And by the time you get to the Planck constant, you put so much energy into that the actual information is scrambled like a black hole. Energy density. And that's basically what it is. It's like having one particle here and then a wave function. Then you put a particle on each top of the wave and you put energy in to increase the frequency. The waves get nearer, 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 nearer. It will not meet it. And you will break the fundamental laws of the universe. That's a very abstract way of thinking. So really they think that particles, they can be anywhere. They can be, here, 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 because we can't measure them. So you can know where they're going and it's very fuzzy, but you can't pinpoint them both at the same time and the momentum. Now, I'm not sure that explains it. Probably people going like, what is this? But
did you use that as a pickup line when you were saying?
I'm not sure there's many people would try it. I'll try it, actually. Might be an idea. Thank you for that.
So you talk about let's say the equanimity that Heisenberg was able to derive from this moment, this revelation. This may be a stretch, but another thing that occurred to me while I was watching the show, I always got the sense from your performance that Walter White couldn't reconcile living in an imperfect world with the elegance that he found in science and chemistry. And that is in part what led to his volatility or his fragility. Yes or no?
You're reading a lot into that. I mean, and that's...
I'm not the only one.
But that's what art should do. It allows the viewer to interpret what you choose. But it's not necessarily what was intended. We don't know. My own description of the formation of this man was that his ego was in check for the longest time. He was a man who caved in. He made poor decisions, business decisions that restricted his growth. He brilliant mind in chemistry. Why is he teaching high school? Well, I really had to put that to the question, and my answer was because of the poor decision making that he expressed in business, he chose teaching because it's unassailable. If a brilliant person says, I'm going to go teach, people would say, oh, wow, that's really great of you to share your knowledge and your wisdom of what you have to do that. But in essence, it was him hiding out because he couldn't confront his own failures. And what was he left with? He was left with looking into his students' eyes, this sea of apathy and boredom, and it just crushed him that they didn't have any sense of excitement about this. And there's that little moment in the first episode when he kind of gets lost in his own little, very rudimentary experiment, and he shows, how colors can, look at that, and he gets excited, and you get a glimpse of what it could have been for him and what it was for him in the beginning, how he got excited about the science and being invested in it. And then he takes that smile and he looks out to his students and they couldn't care less. And it just crushes him. And it diminishes him as a person. So was living in a crusted over core of a soul. That's where I went with my development of the character, that I always look for the emotional core of a character. I need to find out what the emotional core is of any character I play so that I can bring that in as the foundation, so that from that I can grow, and I can then, once I have that, I know what he'll wear. I know what his hairstyle will be. I know how his weight should be. I'll know all those things, but I won't know them until I get that core emotion. And I was struggling with Walter White because I couldn't tap into who he was until I realized, oh my God, he doesn't know. He's a lost man. His soul has been covered over and calloused over, and I was not able to tap into it. It's not until he chooses to go down this path and finds himself in a very odd way, he becomes aware of his abilities. He is appreciated. He feels stronger. And if you'll notice if those who watch the series, I designed this to where when I started Walter White, his shoulders were rolled over. He was a little pudgy. He had this mustache that didn't say anything. It was, I called it an impotent mustache. Because you look at it, like you see some teenagers now who are trying to grow a mustache, and you could see so much skin behind the few strands of hair, and you go, oh, it's so cute. But a grown man, it's not cute. And I wanted this mustache to have people look at me and think, either grow it or shave it. And I wanted that feeling because he was invisible to himself, invisible to society. I knew then what clothes he should wear. I wore yellows and cream-colored clothes and pale greens and things that just blended into the walls until he became Heisenberg. Shoulders go back, chest goes out. He's got a pocket full of money in his pocket for the first time. He can intimidate another human being. That's an aphrodisiac. That's a strong thing to a man. Not a great thing, but it's strong. And all of a sudden he feels powerful. And then that power gets spun out of control. And that's what happens to Walter White. But I wanted him to have this transition from this milquetoast kind of man to this very strong, opinionated, but restricted kind of man. Yeah. So, I mean, that was my journey with him.
Yeah. What response have you gotten from chemistry teachers? Have they approached you to express their either enthusiasm or disapproval of what you've done for the field?
I have not gotten one disapproving remark from any chemistry teacher. As a matter of fact, high school chemistry teachers and college chemistry teachers have told me, said, you made it cool again. All of a sudden, kids are asking questions about, could that happen? Was he able to really? Well, come into the class. Let's talk about that. Yeah. You want to know how this comes about? And it got them talking about it again. And I have parents saying, my kids are chemistry majors in college, and
there was a big take-up, wasn't there, after the series, when the series was airing at the end, a big take-up in colleges from new chemistry students. Yeah.
And this is what I find fascinating, which you've alerted me to, Alan, is that the periodic table owes its origins to the field of mineralogy. It's a fascinating tale, so if you could regale the audience with that, Mendeleev.
Yeah, the periodic table, I remember going to my first chemistry class and thinking, frightened of it. What is that? It looks really dense. There's so much stuff in it. What does it all mean? But when I joined the museum quite early, and so I suddenly realized that everything on this table makes up the natural world. It's the Rosetta Stone of mineralogy. So it's the organization principles of the whole of chemistry, the whole of the elements that make up everything that you see in the universe. That's it, 118 elements, 92 naturally occurring. So it's really frightening when you first look at it. But there's layers of history, both from a social construct, but the people who are finding it, competitive researchers. We read the history of the periodic table, and there's a lot of competition, because people want to have their name given to an element that means you are notified as being a part of the structure of the universe itself, which I think is really cool when you read the shenanigans that some of the scientists got up to. I love the fact that it also reflects naming. There's some elements being known since antiquity that are represented in the table, of course, gold, silver, copper, things like that being found natural. And then there's some elements there that weren't found till much later, like, if I can describe the table quickly, it's done in periods, come down, and rows. The periods are all of elements that are very similar to each other in terms of their chemical reactivity and their properties. And as you go along, you find that they slowly increase in number. So it's 1, 2, 3, 4. It tells you about the abundances of the elements in the universe. It tells you which ones are really rare. But what I love is on the far right, you've got these gases called the noble gases. I love the fact they're called noble. They sit there not wanting to react with anything. They're totally inert, and they were last to be discovered because chemists at the time couldn't get them to react, so they knew that they were there. So to find these things, there were one thing for argon. The chemist was condensing 40,000 litres of air before he got a tiny drop that he couldn't fractionate, measured it. It was quite heavy, so they called it argon, which was new. Many of the elements have Greek names because they're seen as powerful, and most of the people who describe them went to public schools, and they loved Greek philosophy and loved Latin philosophy.
When was the last time that the elemental table was augmented or updated?
I know, probably about 10 years ago, I think. The last natural, well, it's not natural, but the last element was 61. Promethium was found in 1945. That was an element that there's only about 600 grams of that element in the entire crust at any one time because it's radioactive. But it was a gap in the table that didn't waiting to be filled, so they tried to find it. And they did find it because they found that it was a breakdown product of some of the uranium and onwards of transuranic elements. But at about the turn of the century, physicists, there was the invasion of physics. So before that, chemistry was working out what elements were there. Then the physicists invaded, and the X-rays were discovered. Radioactivity was discovered in 1905. Becquerel discovered that. Madame Curie then called it radioactivity. Of course, she has an element named after her, curium. But then that allowed the scientists, one of the biggest things was the Manhattan Project as well. Building a nuclear bomb meant that they were trying to find ways to create elements that could really fission easily so we can explode. So they used to build these massive cyclotrons, and they used to fire neutrons at elements to try and add a neutron to the element, and then build it, and then turn the neutron into a proton, and then that would increase its atomic number and go up. And they just wanted to see how far they would go. So I think the last one is 118, that's Ognassen, named after a physicist. But it's really at the limit, because those elements, from about 112 upwards, few atoms are made, and they immediately disintegrate because their nucleus is of protons and neutrons that are so big, it's like they're burping out radioactivity because they're just unstable.
In the scientific world, is it pretty much accepted that this is unfinished, that you leave it open? Because are you convinced that there will be new elements found at some point in our future?
No. This is finished in terms of elements, unless you want to add some to the end. 119, 120, 121. I mean, the elements are really defined by the number of protons in the nucleus is the atomic number. So number 1 is hydrogen. So that's got 1 proton. Number 2 is helium. That's got 2 protons. And 2 neutrons keep it neutral, with electrons going around the outside, negative charge, the same amount of protons, and that makes it neutrally stable. But there's nothing you can fit in the middle. It's not it does not define as an element. There's nothing that will fit in the middle of that.
This is what I can't get my head around, is that you just said the scientists somehow knew there was a gap.
Yeah, well,
how did you know that
this is where Mendeleev comes in 1869. He actually, this guy at Mendeleev, a fantastic chemist. Many people have tried to, let me put this in perspective. The mineral collection upstairs goes back to about 1680. That's when people started collecting and putting things in Europe in order. And so the mineral collection is the products of all the minerals you find on Earth, and it's defined by mineral species. Mineral species is a naturally occurring inorganic compound that's a regular composition and a regular structure. So this was the products of the world. Nowadays, you have about 6,500 species, would you believe, make up the entire planet of Earth. That's how many we know, independent minerals, far less than biology, where, a filer of ants will be like 100,000 ants. But we still call them species. But the scientists at the time were basically, at the beginning, and they were burning everything. So they're burning everything, see what would happen. They would look through spectroscopes at the flame, and they'd say, oh, the flame's gone red, and that's lithium. So they burn another mineral and say, oh, that's lithium as well. And then they burn another, that's blue. What's that? We don't know what goes blue. But the spectroscope was discovered, or it was invented. So basically, it's a prism of light. You look through that and you hold it up to the sun, and there's a whole series of lines, and they're called the Fraunhofer lines. And those lines, bunches of them, are equivalent, a fingerprint to the elements that are in the sun. And so when you burn your mineral, you can look at the mineral and say, oh, I've got these 3 lines, that must be hydrogen. Mm. And that's how hydrogen was named Helios, after the sun, because it was first discovered. It wasn't known as a gas on Earth, but it was first discovered by looking at the sun. So they just burned everything.
When Walter White is burning for his chemistry class, what for example, produces?
I think there's one scene where you're burning stuff in a Bunsen burner. Yeah. And that's where you're just saying, look, this is what's happening with we can see what elements are in these compounds because they go different colors.
Nuclear waste that I was burning. Yeah.
No big deal.
And so what's great about this is after this, when the spectroscope was invented, people then started using other means to look at minerals, like they used to separate the products of the burning and then do burning on those and look at the salts. So it got much more complicated. But then it was the physicists that came in, and then allied with that was trying to understand the structure, the atomic structure itself was something. So with Mendeleev, go back to Mendeleev, he did everything by weight, but then you noticed that, all right, I've isolated this element, it weighs about 40 grams, this one weighs 56 grams, 58 grams, whereas all the ones in between. So it made them think there might be something between that, but it's like doing a jigsaw puzzle without a picture, not knowing how many pieces you got, which I think is fascinating. So
I'm sorry to be dense, but how do we know that there's something between 56 and 58?
now you're thinking like Mendeleev. Most of the people before didn't. They just had lists. But he said, well, if we put everything by weight, there are big gaps. So maybe there's other elements between that fill those gaps. So he proved it because he called one thing silicon, which eka means like. So he said, in this gap, there's going to be something like silicon, but we don't know what it is. And so there's a mine in Germany, the Himmelthurst mine. We have some beautiful crystals of a mineral called iGyrrodite, a silver germanium sulfide. But we didn't know germanium what it was. So they took some of those crystals, they burnt it, smelted the silver off, the sulfur went up into the atmosphere as a volatile gas, and they were left with this weird, strange-looking element that had exactly the same weight that Mendeleev predicted, exactly the same properties in terms of its density, its boiling point, its melting point. It was spot on. Suddenly, it was the chemical world just went, we discovered it. And from that point, they started trying to fill all the gaps. And that sort of scientific wonder makes you want to do more. And eventually, there was real competition about filling the gaps up and just discovering nature. But what I love about it is that the chemistry drove the physics as well, because then the physicist says there must be some underlying structure to all of this. And once they found the underlying structure of electrons, at first they thought the electrons were going around this positively charged nucleus. Quantum mechanics came in. There was a solar system model, they called it. Like, they used to think, what you do science by thinking, let me look around me and see what's similar. Wow, it looks like you've got the sun and the planets. So maybe the nucleus and the electrons are that as well. But then they realized that when they did some experiments and they saw things come off, X-rays and things, the energy levels weren't quite right. So they changed those planet rotations to electron shells. So they realized that electrons were in discrete shells, that when you put energy in, the electron would jump to a shell, and when it came out, it would release energy, and that accounted for the energy that was being released. And so it really drove. And when you look at the reactivities and the chemical reactivities of the elements on a periodic table, it tells you that it's filling the electron shells. Once you get to the noble metals, which you spoke about earlier, all the electron shells are filled, so they just don't want to react with anything. They don't need to take any electrons or share electrons, which is what chemical reactivity is.
So while we're talking about structure, be remiss if we did not talk a little bit about crystal methamphetamine. Some crystal meth.
What do you think? Good product?
What does crystal meth have to do, this shape of crystal, have to do with the crystals that you study in your field?
Well, I'm not an organic chemist. I didn't like organic chemistry because there's just too many substances that have the same name.
Inorganic means
organic. So carbon, hydrogen, oxygen compounds, throw a nitrogen here and there.
That's organic.
That's organic chemistry.
Inorganic is minerals, things
minerals,
that produce
all the other elements coming together.
So what properties, if any, do they share?
They probably share a few elements, obviously. You can make crystals out of organics as well. When I look at that, when I first started music, I had to describe minerals and see what you see. So I'd say they were sort of frosty, long, prismatic crystals with a poor termination, with not much luster, because luster tells you how hard they are. Many crystals have a beautiful termination of crystal faces at the top. These don't. So they're probably quite friable and delicate, and you could easily crush them into powders if you want to.
And then so underneath the hood, what's actually happening?
When you see a crystal, it has lovely faces sometimes that make the boundaries of that crystal. These are called crystal faces. And all that is reflecting, the faces reflect the internal crystal structure, which here is represented by a series of hexagonally shaped interlocking crystals with the silicon and oxygens represented.
I noticed, Bryan, in the pilot episode, there's this moment where Walt is looking and he's got this kind of small plaque that talks about his contribution in crystallography to having received the Nobel Prize. It's like this tiny footnote that you almost miss. You know what I'm talking about?
Now that you mention it, it's ringing a bell, but I haven't seen the series since it came out. So it's been a few.
Almost 20 years, yeah.
Yeah, I guess it is,
Yeah.
18 years, yeah.
You had a Nobel Prize in proton radiography.
It wasn't, no, I think it was a notification of being considered.
Considered.
One of the considerations, he was considered, I was in the running at some point.
And that was his field. He was a crystallographer.
Okay.
You say so, man.
I'll say yes. I'll say yes.
So would a crystallographer know how to explain the difference between these two things?
Well, the one on the right to me looks like poker chips. And the other one looks like an astrological sign.
I think that's an on-point observation.
Me too.
Yeah.
I think that really what they're showing there, amorphous versus crystalline. So when you have substances cooling down, if they cool down slow enough, the atoms can come together and form crystals and a regular atomic arrangement. If you do it too fast, if a fluid crystallizes too fast, it cools down too fast, the atoms don't have time, so they form this disarray of atoms that are loosely linked, and that's called an amorphous structure. So there's no internal symmetry that really defines what a crystal is.
So do crystalline solids always make that configuration?
No, they don't. When crystalline solids fall into only 7 crystal systems, 7 crystal systems define the symmetry of what you're looking at.
Okay.
When we talk about symmetry in mineralogy, we talk about how many times you can turn a crystal so it looks the same. So take a cube, 1, 2, 4 times, it has one axis, well, it has a 4-fold symmetry. But if you go to the corner, it has a 3-fold symmetry. So it has one 4-fold axis, 3-fold axis, and that defines a cubic symmetry. As you go along this group, the symmetry lessens, but a great mineralogist will be able to tell by looking at a crystal what the symmetry elements are and what the crystal system is, and then you can have a punt or identify it just by that. If you know.
Did you say you can have a pint?
It's an English word, a punt.
I hope you're all listening. We will be testing you later on this.
But that basically is symmetry. Is everything in crystallography.
So how thrilled were you when this scene first came?
You ordering a new rock?
I'm bidding on a new mineral.
The rocks, Hank!
No, they're mineral. So, rock collecting? They're minerals.
Go show the boys your new rock collection.
You have a rock collection? It's a mineral collection.
You're looking at a rock at 2:24 in the morning.
It's not a rock. This is a mineral for like the 10th time.
I remember watching this, and I literally punch in the air.
This was your
literally. I think I can't believe minerals were on prime time TV. It's awesome.
It is sexy.
Friends were phoning me up saying like, "So this is what you do?" Because no one can really understand. You know, in the working museum and the job that I do, they think, "What do you do? You look at rocks all day." I went, "Well, sort of, yeah." And this was fantastic, but there was an underlying boredom to it. The way it was presented, it was like, I think Hank was there. He needed something to occupy. He had a fantastic mind, I think. He needed to be occupied and still think things through, but be arranging things in an order that he could try and fathom. And that just replaced it while he recovered. And it sort of settled his mind somewhat. Like stamp collecting and all that sort of thing. This is the same sort of thing.
Bryan, how would a subplot like that get developed, for example? Or what's your take on why Vince put that in there?
Well, because human beings are complex, and if you are a person like Vince Gilligan, who just doesn't accept the easy way, he agonizes over every element of it. I first met Vince 10 years before Breaking Bad. I did an episode of X-Files with him, and that's where I learned his brilliant mind, is that in this little short thing, he had my character, who was a horrible person. Oh, you see him there. You could just look at him. You could tell he's horrible. He's hirsute, and that means horrible. And he was just a vicious, awful human being. And David Duchovny's character was in the front seat, and he was actually driving, and the conceit was he had to drive at 80 miles an hour in the westerly direction or my head would explode. You all know what that's like. And so, what Vince did is different from what most writers would have done. Most writers would have written my character to be sympathetic, so that the audience goes, yeah, he's a nice guy. You should save him. Save his life. Go, David Duchovny. Save him. Yay. And maybe he does, maybe he doesn't. But Vince wrote him to be a despicable human being. Why? Well, because he wanted to put a moral dilemma in the center of his main character. Do I save this man's life simply because he's a human being? He wanted nothing more than to pull over and let me die, but he couldn't do it because it wasn't who he was as a human being. So that gives you an insight to the depth and the layers of it. Did he have to have Hank be into minerals? Of course not, but it does give him more layers to that man. Whether or not it pays off in part of the plot discovery is not as important as layering these characters with interesting insight and habits and hobbies and things like that.
I'd like to dwell on the X-Files chapter, because I think for both of you, who are both at the top of your respective fields, and I think can be a source of inspiration for anyone coming up in the arts or in the sciences, because I've heard you speak to the element of luck and how the role that played. Could you tell the audience about how you got Breaking Bad and its connection to this taping?
Yes. I always tell young actors, and if there are young actors in this audience tonight, there are 4 things that you will need to have a career as an actor: talent, not a boastful one, not pounding your chest, just a quiet confidence that you can do this, that you have talent. You have to have patience and you have to have persistence, which seem to be contradictory at times, but they actually work in tandem. And then the last element is luck. You have to have a healthy dose of luck sprinkled throughout your career. And no career is made without luck. And I tell you that as a sign of encouragement, that there are these things that you need to look for. There are elements that you need to look for. You can prepare for luck by being ready, but you cannot manufacture luck. It has to come on its own. But I was just going along, and I believed in this philosophy that I wrote and directed a little independent movie, and I happened to be back in Los Angeles for 4 days from being away, and I got this audition for X-Files. I got the show, I did the show, I met him, and the character that he wrote, this horrible human being in the background, was the seed that planted in Vince Gilligan's mind. He said, if I'm going to do a show now where I'm going to ask an audience to align with this man, they have to at first have some empathy for him. And so he created this, he's got a family, has to have a second job in order to pay for his son's special needs and whatnot. But then I'm going to start turning that dial and have him do, oh, you're still with him. Oh, you're still rooting for him. How about if he does that? Oh, still. Okay, how about this? And he said, I'm going to keep turning that dial and test the audience and your allegiance to my character. And I would get worse and worse and worse and have him do that. But I was very lucky to have met him to do this, because he was my champion to get Breaking Bad. And I had just finished 7 years of a show called Malcolm in the Middle, where I was a sweet, goofy, I loved doing that show, but it was silly and goofy and fun, and the studio and the network who were doing Breaking Bad could not believe when Vince Gilligan said, I want the same guy who did the dad and Malcolm in the Middle to be Walter White. And they were like, no, and so he sent them at the time the disc of that episode, and they watched me being this horrible person, and they thought, oh, okay, so actors can do a range. Oh, okay. And it was very, very helpful to my career.
And in the sciences, you are not immune from this element of chance as well in your career path. And again, because perhaps there are some budding scientists, young folk coming up, could you tell a little bit about the shape that your path took?
Yeah, but that's me on the left, Brian.
Is it really?
On the left, yeah. In case you're on
Yeah. When you had hair.
Thank you. My path was not what you would expect. So I came straight from school at 16 years old. When I was at school, they wouldn't let me do languages and science at the same time. So my mum said to me, you're leaving school then? So I said, what am I going to do? And she went, what do you want to do? And I said, I'd like to be an assistant scientific officer and I love minerals. So she went, okay. A few weeks later, got a call from the museum saying you got an interview for an X-ray crystallographer. And I was like, what? So I came to the museum, I've been to the library, I'd read up about X-rays and crystallography. A huge panel sits in there and they asked me questions, and it was quite clear I didn't know what I was talking about. Well, I didn't know what I was talking about, but I had no experience, and it was almost like I tried to blag the interview at 16 years old. I was terrified. My dad was outside waiting for me, like...
Outside of this building?
In this building, yeah. And so, and then a lovely lady called Eva Fayer, who was head of X-rays, was looking at me, and they actually discussed my interview while I was there, which is really bizarre. So I'm sitting there, clearly unsuitable for the role. I was like,
at this age,
wow.
16?
Yeah, 16. I was sitting, and I was like, oh, he'll be okay. And then Eva just said this. She went, maybe we'll send him upstairs to curation to sort the old boys out. And I just sat there and thought, that's a very strange comment. Anyway, they went, thank you. I got a letter. Unfortunately, you cannot be an X-ray crystallographer, but we'll give you 6 months in curation, in collections, to just learn about mineralogy, and you can sort some collections out. So I came to the museum. I worked so hard for those 6 months. My mum was a wonderful lady. She said, your foot is in the door, and now is your only chance, so take it. And so I took it. And I used to be quiet. I thought to myself, my mum said, be bold, talk to everyone, you're not going to embarrass yourself. So I was. And on my last day, they made me clear my desk up. I went down to the head of mineralogy, and he said, what are you going to do now, Hart? Because it was called by your surname. And it said, I said, I'll come back in, I'll go and get my A-levels, I'll do a degree, and hopefully I'll come back. And he said, you don't need to. You just sign this, we've got a permanent position. So I went back up to the office, and all the guys are clapping, and I'm like, wow. My mum went home, mum burst into tears, and my dad...
You were 16?
16. My dad said, I don't believe it. So I started to work the next week, and these two fantastic guys, Max Hay on the right-hand side and Campbell Smith in the middle, they were really the leaders of their field in crystallography and mineralogy. And basically, I had to learn what they knew about the collections and about the principles of science for about 5 years with these two.
It's worth making a distinction between, because you obviously impressed them. You obviously knew what you were talking about. They saw the passion in the field. Now, but at 16, of course you don't have any experience.
That's right. I think the thing for me was that I think they didn't, someone from like Jesse Pinkman, and this, I do great chemistry teachers, and someone who didn't know maths. I was awful at maths. So they say, look at these crystals, here's the maths behind the crystallography. And I say, sorry, I know nothing about that. I'm a visual person. So they got me measuring crystals visually And then slowly we had a great relationship because I tested them in terms of, we've got to deal with Alan this morning. I mean, one of the great things is Campbell Smith in the middle. He got the position of crystallographer over Arthur Holmes, who was one of the greatest scientists this country had. And the reason that he got it is because Campbell Smith's Latin was better in 1930. And so I go to coffee with them and they'd suddenly talk in Latin. And I'd be standing there thinking, but then they'd say like, Alan, and I'd say, you're talking about me? And they couldn't believe that I would talk like that. So in the end, we just had I think it worked both ways. My lesson from this is that just don't be afraid to approach people and ask the question and push open the doors, because I found most people are really accommodating.
To express your passion for something,
definitely,
is the same in whatever field.
Yeah.
But not to the point where you're trying to, lie about getting away with something, because you'll be found out to be a charlatan quickly.
Yeah.
So it's Bryan's twin law of persistence and patience.
Yeah.
Speaking of, we have some questions from the audience. Alan, what are your favorite minerals? To the mineralogist, what is your favorite twin law?
Oh,
I don't know what that is.
Question. So what I love gem crystals. So I love crystals of emeralds, crystals of rubies. I love tanzanite. I really do enjoy those. That's a nice mineral you just put in. Well, there's lots of twin laws. I think the twin law that I like the best are the calcite twins. So you get twins. Calcite, when it grows, sometimes there could be a defect in the structure as the crystal is growing, and that slightly offsets the structure, and it grows two crystals that have a relationship to each other in terms of angles. And they can be very varied in what they look like. And sometimes you get rare crystal twin laws, and you can get quite common twin laws.
Looks like a dragon, the one on the right.
See this one. This is amazing. This is a gold specimen, a native gold specimen from the Colorado quartz mine in Arizona. Strange, but that's what it's named. It's a massive crystalline gold. They found it a few years ago. It was an old mine from the California gold rush. And the great thing about this was they used metal detectors. They reopened the mine just to see what they were found, and they was literally found about 2 feet inside the rock. So they uncovered it and they etched it away, and it was one of the most remarkable specimens. What I find fantastic about gold, all elements you see are made in dying stars. We're all stardust. Everyone in this room is stardust. What's great about gold is a super heavy element, so it requires quite a special formation. And a few years ago, we know that heavy elements are made in neutron stars, which are stars made of neutrons, super dense. So 1 teaspoonful would weigh about 6 million tons. Imagine that. And there was a merger of two neutron stars a few years ago that was caught by a gravitational wave. We have beautiful detectors in astronomy that look for gravitational waves. And they found a gravitational wave that they pointed a spectrometer at this where the wave came from, and they found elements being made in the spectrograph as the neutron stars crushed together, exploded into a kilonova explosion, and it expanded at 20% the speed of light. After 1 day, it was the 50 AU across, which is an astronomical unit. That's the distance between the Earth and the Sun. So Pluto's orbit is 39 AU, and this thing had expanded. And what I'd love to say is that when they measured the expansion of this cloud, nuclear synthesis, that was the creation of heavy elements, was taking place. And they estimate that 10 to 15 Earth masses of gold atoms were made in that moment and then flooded the cosmos. And so this gold really is those atoms that occurred as discrete particles. But our Earth formed 4.5 billion years ago, captured some of those atoms. We have a recycling process in the Earth of change, constant change, forming an ore deposit, and that was mined. So when I see the specimens like I just think that is incredible.
This one's for Bryan. Was there a particular scene that was the most emotionally challenging for you to film, and how did you prepare for it?
Yeah, the biggest challenge I had was I think it was in the second season. Jesse's girlfriend got him hooked on heroin, and We initially shot, the initial script of that was that I was so upset with her for doing that, that I pushed her on her back so that she would choke. This is a delightful thing. She would choke on her own vomit and die. And this is the second season. And the studio and the network went, wait, no, it's too soon, no. And I thought, and I was shocked by it as well. Like the turn of Walter White to Heisenberg was happening too quickly. So we talked about it, and Vince came up with a different idea, and it worked. And that was, I'm shaking Jesse to try to get his attention and wake up, and that jostling just made her flip to her back, and I didn't notice it. And then she starts choking, and we talked through this whole thing, and I said, my human impulse would be to save her, do something. And so I run to her side of the bed to save her, and that time it takes to run to the other side of the bed made me pause and think, wait a minute, this woman is going to kill my partner because of what she's done to him. So when I was preparing for that, and he actually let her die just by omission, an act of omission. And when I was preparing for that, I would write down, like I do on all emotional things, a pro and con list. Why should I save her? Why should I let her die? And I'm writing down all these things. And one of the things that I wrote down in the why should I save her was she's young enough to be my daughter. She could be my daughter. And I'm just writing all these things down. And, you know, it goes into the subconscious. And when we were shooting it, I actually looked at Kristen Ritter, the actress playing the role, and the cameras were on me as I'm desperately contemplating what I should do. And I'm looking at this, and I'm emotional, I'm shaking, and I'm seeing her, and she is acting really well off camera for me, full on. And all of a sudden, I see her face kind of disappear, and my real life daughter's face show up and choking to death. And it just grabbed me. And as soon as it arrived, it went away again. But that's what they kept in the show. And it was like the most, I had a really strong cry after that. It was like, oh God, I'm exhausted. Because it's been proven to us that whether you go through an emotionally traumatized moment voluntarily or involuntarily, your body doesn't know the difference. It goes there for you. So, like I'm doing a play at the Wyndham's Theater called All My Sons. I hope you all, and every night it gets me, and I go into this abject despair, and it just goes there. Because I've been doing it for so long that my psyche is trained to go through the door, just step through into the unknown, and you'll find whatever you're supposed to find there. And so that was the most traumatized ever.
Similarly, someone wants to know if playing a man dying from cancer, what that effect had on you, maybe in your relationship to mortality.
It does. I mean, I think that is a little different, because I think by now, and when you're a person of my age, even then I was 50 when I was doing that show, in my 50s. I knew people who have had cancer and terminal cancer and were dying of cancer, and so it was something that I could glean from my own personal experience, and it was. But what I found to be so rewarding in a very odd way, I've had so many children of parents who have died from cancer approach me and say, "You're not going to believe this, but when my father had cancer, we watched your show, and he needed to watch it. He wanted me to watch it, to go through this with him as a cathartic experience that they could share. And he said, I maybe a dozen people have stopped me on the street and have told me about their own personal experience with someone who they know and love, and how watching this television show with them was therapeutic in a very strange way.
Alan, someone wants to know what your first response was as a scientist seeing this show come out as a smash hit that focused on science so much.
First of all, I loved the show. It was amazing. I loved that in the show there was terms that you recognize from a scientific perspective. You mentioned gas chromatography. You mentioned what we need a synchrotron for this. You spoke about chirality in molecules. It was like, wow, these terms probably not many people know what he's talking about. That someone's done their research really well. Going back to the cancer thing, I think we're all very scared of getting diseases. I know sometimes I think, my friends, I'm getting older now, and they say you're in Sniper's Alley. Now let's see what happens, So I watched it, and sometimes I felt despair, but I think that's why we rooted for Walter White, because he was living his life as much as he could. Okay, the wrong side of the road maybe, but he was living his life, and he was. And he was doing something that he maybe, having an emotion that maybe he wished he'd had all his life. But this was the push that made him do it. That's how I saw it.
It was, and then it also exposed his own frailties as a human. Yeah. That he was also prone to egocentric behavior and damaging to everyone around him. And that's basically, it's a show. The show was really about poor decision making, really,
Yeah. And it's interesting you say that you must have felt the audience are going to hate me this week for all the things you had to go through. But I found that all my friends, we speak about it, I think we still rooted for you all the way, right to the very end, even though when you sit back and contemplate what really went, it's like, wow. That's deep.
Well, I did lose a lot of people. A lot of people left my allegiance and went over to other sides. And that's fine. I'm willing to not be the good guy. Yeah. Because it was important. In fact, there was a scene we were shooting, one episode, and I wouldn't read the next episode until we were just about done with the one we were currently shooting. So there was an episode, I think it's in the 4th season, where the little boy was poisoned.
Oof.
Right? And Jesse thinks it's me, and he's so upset and so angry, and he's going to kill me. I am thinking, why would I do this? I have no reason to do this. Who stands to benefit from this? It's Gus Fring. That's the guy. He's doing this. Don't you see what he's doing? Well, I acted that in actual legitimate point of view, because until I read the next episode, when I realized, it was me. Oops. That's how great a writer, and I think that's where the efficacy of the density of the characterization comes in, is that Vince writes with density, so you're holding on to a lot of things, and there's a lot of complexity in the characters and the relationships, and so you can get lost in that. And even I was lost in that. I didn't know that I poisoned that boy. And I thought, oh my God, he's really turning that dial.
That was a choice you made to not read the script, wasn't a requirement.
It was a choice because Walter White, then to Heisenberg, was on such a topsy-turvy ride that I would get it confused. If you know 2 scripts ahead, you might accidentally infuse something in what I'm shooting now. And I thought, it's such a roller coaster ride for him. So let me just take it one by one.
For all of us, I think. Okay, this one's a little above my pay grade. Alan, This is from Alice. Is there any research being done in the museum in relation to mineral structure replacements to lithium-ion batteries? For example, petrovite-based sodium-ion batteries.
That is a deep question. That's more like the material sciences. I'm not sure. But I do know that we, as a museum, we do a lot of work on how we manage sustainability of the planet. As you know, the rare earth elements are going to be used more and more. You hear it on the news all the day about we need more rare earths to provide energy, batteries, our mobile phones. They take so much, and these rare earths are quite rare. So a lot of our thought is how do you sustainably mine this material, use it without too much damage to the environment itself in terms of waste management and impact. That's a key point of any sustainability action we have to do.
I have a layman's question for you. Now that we know that ice was found on the moon, is it possible to separate the hydrogen and oxygen for use of hydrogen power?
Absolutely.
It can be done.
It can be done.
There's a certain quantity that needs to be found.
I'm not sure the process, but it definitely can be done.
Okay.
I think what's interesting about the moon is that we've initially thought it was absolutely no water there whatsoever. When the astronauts went and collected the raw materials and came back, they were bone dry. But only later did they go to see the poles and think like, oh, there's something in these craters that never see the sunlight, and the ice is preserved inside that. And they always saw the moon as a sort of staging post in the past, then
it's like a petrol station.
To go to other planets or be more efficient in terms of using less energy to get somewhere else.
Now, can you actually separate and use the oxygen for human consumption?
Yes.
You can. Wow.
Yeah. As long as you have the right purification, it's still H2O, whatever capacity it is. There's no other thing in it that makes that difference. Just make sure you don't get any moon dust in there or anything like that. But yeah, you can.
Okay, final question for the evening. Bryan, what was your most memorable experience that you hold on to making Breaking Bad?
I'll go to the last episode, I suppose, where he honestly, he wanted to see his wife one last time, and he's talking about his journey. It's now 2 years later. He knows he's going to die very soon. He didn't know he was going to die that day, but he probably did. And she gets fed up with him and frustrated and said, don't you dare say that you did it for the family. And then I was so pleased to see Vince write, no, I did it for myself, and I was good at it, and he was like, so he was able to at least, even though it was still egocentric comment, he was able to be honest and finally say, here's what it was. This journey was for me, and I don't regret it. And then he went out and got himself killed. But the last image is what Vince wrote. He said, he's like, instead of taking out a picture of his wife or kids, he went to this lab, and he's touching the lab equipment with such adoration and love. And you realize, oh, that's really what it was. His true love was the last thing he saw and the last thing he felt before he dropped.
Thank you so much, folks. Please help me give it up. Bryan Cranston and Alan Hart.
Thank you very much. Thank you. Thanks for coming.
If you came here to learn about crystal meth and feel misled, you can check out a brilliant episode on the topic called Methamphetamine, the Most Misunderstood Drug, which was produced by our friends at the Science Versus podcast. Science Versus is the show from Spotify Studios that finds out what is fact, what's not, and what's somewhere in between. Science Versus is available on all major podcast platforms. You can catch Bryan on stage in Arthur Miller's All My Sons at London's Wyndham's Theatre through March 2026. To find out more about Alan's work, You can visit his website, alandhart.com, or follow him on Instagram at alandhart. Sing for Science is co-produced by Talkhouse and made possible in part by a grant from the Simons Foundation. Our music is by Panoram. Social media manager and video editor is Bailey Constas. Location recording was provided by Bespoke Media, and our digital producer is Keenan Cush. Special thanks to Yvette Modenu, Camilla Tam, Robbie Watts, Hannah Douglas, Caroline Smith, and everyone at the Natural History Museum for making today's episode possible. If you like Sing for Science, the best way you can support us is to give us a review, tell a friend about the show, and subscribe on your podcast platform of choice. For more information, please visit singforscience.org and follow us on social media at Sing for Science. Thanks for listening.